So I've got the SmartSocket board that we assembled in the clamp here with the tube installed in it. I don't have the PIC processor in it, I've just got the open socket. I'm bringing 170 volts DC to the board from my Heathkit, what model is it? IP17 high voltage power supply, which is here on the bench. I've then got a Rigol supply supplying 5 volts. And what I'm going to do here, as soon as I spot the schematic again, is without the microcontroller installed, I can simply go to each pin in the microcontroller socket that drives one of these transistors, and using this little red wire here, which is to +5, I can turn that transistor on, and what I can do is get a look at how much current each segment draws. Wish this was a bit more stable here. How much current each segment draws. I've got my milliamp meter here. Oh, it's really dirty. So this is just a milliamp meter movement that I picked up ages ago. Just mounted in a metal box, and I got this specifically for dealing with NIXIE tubes because it's got a nice NIXIE tube range on it, which it goes to 10 milliamps. So I should be able to turn a segment on here, and you can see that I did. And that segment's drawn about 1.5 milliamps. And if I work my way through the board here, I should be able to go segment to segment. So pin 2, pin 3 has another segment on it. That's just over a milliamp. Pin 3, pin 2, 3. Then it looks like 6, 7, 8, 10, 9, 8. So there's 6, 7, 8. Really, in this case, I am safe to completely walk around all the pins on here, except for ground. But you know, the milliamp, probably not connected. There's the caret at the bottom. So all I'm doing is turning each one of those high voltage transistors on by applying 5 volts to the base. That 5 actually through a 33 k ohm resistor to the base. So we can simply walk around the tube here and look at the current draw on each segment. I shorted the 5 volt power supply there, but it's current clamp, so it's fine. And we can see on the meter movement, as I light up segments, that we're drawing about 1 to 1.5 milliamps per segment. That's probably the heaviest segment right there at 1.5 milliamps. So the full tube on, there's 1.5, 2.5, 2.6, 3.6, 4.7, 5.8, 6.9. So that's actually up to 7. 7.2, 8.4, that's about 10 total, 11.4, 12.6, 13.7, 14.8, 15.8, 16, 17.4. So just kind of moving around here and just taking a quick guess. It looks like all segments lit on one of these tubes. End circuit here is about 20 milliamps. I have actually ordered 5 or 6 DC boost converters that'll take up to 12 to 18 volts in and produce 170 volts DC. And I will be using 1 per tube here. Those are good for in the range of 30 to 33 milliamps each. And if I want to be able to light all the segments and all the tubes, in this case we're going to have 6 tubes times, call it 25 milliamps, is 150 milliamps of current flow. So I made the call that 1 little power supply converter per tube would make sense. The little kits are about $10. They should work well for this. As you can see here, we can walk around and light up segments and basically see that things are working as expected. I have no idea if the SmartSocket controller, I have programmed them. We'll do another video on that. Has any kind of a self-test mode. It didn't look like it. I don't know if at power up it does anything. But what I'm going to do is stand by the high voltage supply, turn off the +5, just take a quick look at the high voltage supply to make sure that it's bled down, and it has. Well, no, it's still at about it's about 40 volts at this point, and rolling down. And I'm going to go ahead and insert the microcontroller. I do need to discharge that power supply first. I've just got a couple screwdrivers here that I'm using to short that output cap on the high voltage power supply out, just to get the voltage down to something reasonable. And at this point it's down at it's under a volt, so it's fine. I've got the 5 volts off. I'm going to go ahead and insert the microcontroller into the socket. And it's in, pin 1 is up. I will bring up the high voltage supply. And I didn't know whether I should have seen something happen there or not. I didn't. I'm going to assume the microcontroller's running. It would have been nice had it actually woke up and done something. It might be interesting to create a custom program to exercise the tubes. I may do that. I was kind of hoping to see that do a little something, do a little dance of some kind. I'd power up on the tube. Just make sure I've got voltages where I expect there to be voltages. That would make sense. I should have plus 170 here. And plus 5 here. And I do. So I have got power on the device, on the microcontroller. I'm going to assume it's operating. It just hasn't received any instructions. Really, the next test in this is to get a laptop up here and to send some control codes to it and see if we can get it to light the tube up and do anything. But this is a positive sign on the first board that I was able to light up various segments. I am assuming I was able to light up all the segments. I actually didn't pay enough attention to know that for sure. But I can go in and do that now. Just got to be careful here because there is high voltage on the board. Back onto the plus 5 volt pin here in the IC socket. Bring on the 5 volts, bring up the high voltage, and I should be able to go to each one of these resistors and light a segment. Just got to be kind of careful here. There is high voltage on the board. So I just walked through all of the driver transistors and hit the resistor to the base and saw a segment light up. So all of those are working as expected. There is an ammeter here on the Heathkit supply. The problem is its scale goes to 150 milliamps full scale, so it barely moves. you know, when I touch one of these versus there, you can see I've got, you know, 1.6 milliamps. Trying to get contact to 2 segments like that. Yep. Got to be a little careful here because I am working around high voltages. 170 volts will make your day interesting. Well, that's pretty interesting. It's definite progress. The next step in this will be to get the laptop up here. I've got to find a USB serial adapter that's TTL level signals. I know I've got a couple here someplace. I've just got to find them. Anyhow, when I get to that point, I will get some video shot at it and get this edited.